Lidia Maria Cervantes, and I worked with Dr. Giancarlo Lopez Martinez from NDSU to create this project, Becoming Immortal, Understanding Anoxia hormesis in the Alfalfa Leaf-Cutting Bee. So, what is Anoxia hormesis? Treating insects with anoxia, a total lack of oxygen, has shown short and long-term benefits such as increased survival, longevity, and reproduction in beetles, moths, and flies. Defined as hormesis, a potentially deadly treatment like anoxia can improve organismal performance when applied in a short dose. Cutting out oxygen can decrease the amount of oxidative damage produced while protecting vital tissues. During exposure, insects become dormant, decrease their oxygen usage, and boost the production of mitochondrial defenses. If you are in biology, you may have heard of heat shock proteins, and these are some of the mechanisms by which the tissues of these insects become productive during this state of anoxia. Then, when they awaken from the state of anoxia, they are stronger than before in many ways. So we worked in the Insect Cryobiology and Ecophysiology Network in Fargo, North Dakota. This is where the alfalfa leaf-cutting bees, the Megachile rotundata, are found. They are solitary bees and they do not form hives. They form what are called brood cells, and they are a form of bee cocoons where this insect overwinters and have enough resources before they emerge in the spring. We took newly emerged bees and treated them in syringes that were flushed with nitrogen and placed them in a bag and heat sealed. This created a sort of nitrogen tank where there was no leaking of oxygen into this. Then we took the bees and pupae, treated them for 0, 1, 3, 6, or 8 hours of anoxia, and allowed them to recover in temperature, light, and humidity-controlled incubators. After the treatment, we measured recovery time and circadian activity using Drosophila activity monitors, or DAMs. These Drosophila activity monitors were sensors that measured the amount of movement by the insects per minute. A picture of a dam is found right here. Then we tracked the starvation, resistance, and longevity. Starvation resistance was the amount of time the bees lived without food, and longevity is the amount of time that the bees lived with food. These were the results. On figure 1, we can see that our hermetic dose is 1 hour of anoxia because the AX1 treated bees recovered quicker than those treated with a higher dose. Figure 2, hormetic bees also had an increase in activity during the first 3 hours of post-treatment, a classic hormesis dosed performance boost. As you can see, the anoxia-treated bees had the almost immediate recovery in which they had just as much movement as the non-treated bees, as well as the 3-hour bees had very similar movement as the non-treated bees. And in figure 2, we can see that the hormetic bees were even more active after a few hours. And this was also measured in movements per bee per minute. Then, using these Drosophila activity monitors, we also measured the alfalfa leaf-cutting bees' circadian rhythms and how they were affected by anoxia. During the daytime, the movement of these bees was pretty average compared to the non-treated bees. However, we noticed that the anoxia-treated bees for 1 hour, the hormetic bees, did have higher nighttime activity than the non-treated bees, and this is unexplainable so far, but this is a very interesting phenomenon to happen. Lastly, and most importantly, we did find that these starvation and longevity results were very interesting, as the 0, 1, and 3 treated bees with anoxia did experience the same amount of starvation resistance. After 3 hours of anoxia, they do experience a negative effect and a lower resistance to starvation. However, the title of this paper, Becoming Immortal, comes with our final result from the longevity testing. We saw that the bees that were treated with 1 hour of anoxia were living longer than the bees that were not treated with anoxia. Bees treated with 1 hour of anoxia had the lowest age-related mortality, and they are likely to live longer. We also did further research on anoxia treatments on pupae and adults, comparing how these would affect their survival. Pupae and adult bees treated with anoxia had similar survival responses, and further research will elucidate how life stage influences stress tolerance. In addition, we also started experiments to see how these anoxia treatments would affect performance such as flight speed and resistance. In the following clip, I will show the beginnings of our development of this machine, which measured the flight speed in rotations per minute of the alfalfa leaf-cutting bee. After testing their flight abilities with this machine, we didn't get conclusive results, but so far we found that the anoxia-treated bees of 1 hour did perform the same as the non-treated bees. In conclusion, and most importantly about our longevity results, we found that the hormetic dose of the alfalfa leaf-cutting bee to be between 1 and 3 hours. Hormetic bees did not differ from controls in their resistance to starvation, and hormetic bees had a drastic increase in their activity post-treatment recovery. Additionally, hormetic bees had the lowest mortality rate and will likely live the longest according to our longevity results. Further research will look at the anoxia tolerance of earlier life stages, such as doing these treatments in prepupae and pupae. The authors thank Taya Hayes, Dr. Joseph P. Reinhardt, the USDA ARS IGP Research Unit, the ICE Network, and our funding coming from the National Science Foundation Office of Integrative Actives. Thank you to the organizers of the URCAS, and